Hey guys, so in this lesson we're going to go over how to multiply polynomials, okay? So when you're multiplying these, first we got to be able to all be on the same page with what these terms mean. So a monomial just means one term by itself. So like 4x cubed would be a monomial, okay? A binomial, or if you hear the term binomial, that's usually meaning two terms. So you have negative, y squared plus 1 would be an example of a binomial. And then a trinomial is just going to be three terms. So a trinomial would be like a minus 2b plus c, right? It's got three different terms, so it would be called a trinomial. And a polynomial is just the general term for anything with multiple terms in them. So a binomial and a trinomial would both be considered polynomials along with anything else, any number of terms bigger than one. Okay? Now, the way you multiply these things. You all know what FOIL means, all right? So if you just have a binomial times a binomial, you're going to FOIL, okay? And this stands for front, outside, inside, last, okay? But in the more general case, you're going to think of it more as distributing each term, okay? That's going to be a better way to think about it. Think of it more as distributing rather than foiling, just because you're not always going to have a binomial times a binomial. All right, these couple of special cases that I'm not going to run through the proofs with you because I think that you can do those. But these are just some special cases that you could start to catch on and just might save you some time. Of course, you could always expand these on your own and do and you'll arrive at the same answer. But if you recognize these patterns, this will help. Okay, so remember that a plus b squared is the same as a plus b times a plus b. Okay, so when you FOIL that, or distribute it, multiply it, whatever, and you simplify it, you're going to come out to this a squared plus 2ab plus b squared. All right, same thing when you have the a minus b times a minus b. Okay, you're going to come up with the same idea. All that changes here is the sign of the middle term. Okay, and lastly, if you got a plus b times a minus b, this middle term right here is going to go away. It'll end up canceling each other out rather than adding up or subtracting up to get 2 times AB. Alright, so they'll cancel each other out. That's why you only have two terms left. The first one is going to be positive because a times a is positive, and the second one's going to be negative because negative b times positive b is negative b squared. Okay, that's the general idea. Now, let's run through all the examples really quickly. Okay, so this first one, the binomial times a binomial, so think of it as foiling. Right? The way that I think of it is I think of it as distributing. Okay, so I'm going to take the first term, this 2a, and I'm going to distribute it to the 3a and the 4. Right? And then when I'm done with that, then I'm going to do the same thing with the negative 5, distribute it to the 3a and the 4. It's the same exact thing as foiling. Okay, we've got the front here, we've got the outside, we've got the inside, we've got the last. Okay, it's the exact same thing. All right, so we'll work it out, and we're going to get 6a squared plus 8a minus 15a minus 20. Okay, now once you get there, you simplify whatever you can simplify and just leave the results. So 6a squared you can't combine with anything. We're going to get negative 7a minus 20. Alright, the second one. Okay, just don't forget, this is huge, do not try to distribute a squared into here. It doesn't work like that, okay? You only can distribute that if they're multiplied. These two terms are multiplied by each other, then you could do that. But because they're added or subtracted, you can't do that. All right, so instead, you need to think of this as 3c plus 2 times 3c plus 2. Okay, now this is our a squared plus, or this is your a plus b squared basically, right? And if you remember what I just did, right, of course you could do this problem just like we did on top. It's not a problem, you can go for that. Remember that a plus b squared, I don't know why I even put that there. Okay, a plus b squared equals a squared plus 2ab plus b squared. Okay, so 3c squared is going to be 9c squared. A times b is going to be 6c, right? Multiply that by 2, so it'll be 12c. And b squared is 2 squared, which is 4. That's the answer. And if you do it the foiling or distributing method, you're going to get the exact same answer, hopefully. Now, another special case here. Right, if you see exact same terms, okay, same terms, all that's changing is the sign in the middle. All right, notice the 4k is the same, the 7 is the same, all that's changing is that sign in the middle. Okay, that means that you know that all you got to do is take the first one squared, minus the second one squared. Okay, because your middle term is going to cancel out. Once again, you could of course FOIL. You're going to get the same answer. You're going to get some cancellations. Okay, so this could just be 16k squared minus 49. All right, a little bit more difficult ones. We're going to get beyond the binomials, and we're going to add some trinomials in here. So we have a binomial times a trinomial here. That's why I suggest that you think of it as distributing each term. So I got to take this 3x, distribute it everywhere, and then take the plus 1, distribute that everywhere. All right, let's start with 3x. 3x times x squared is 3x cubed plus 6x squared minus 18x. Okay, and we're going to do the same thing with the 1. 1 obviously makes it easy. We could just rewrite that second polynomial there, the trinomial. Plus x squared plus 2x minus 6. All right, then you got to combine anything you can. The 3x squared you can't do anything with, or 3x cubed, I apologize. All right, 6x squared plus x squared is 7x squared. We're going to have minus 16x minus 6. So you're left with 4 terms here. So it's a polynomial with 4 terms. All right, very similar in this example number 5. What's different in this one is we've got the trinomial first multiplied by the binomial. Once again, distribute. Take the whole negative 2xy, distribute. Take the whole y squared, distribute that. Okay? Let's work it out. X squared times x is x cubed. X squared times y is exactly that. Negative 2xy times x is negative 2x squared y. And negative 2xy times y is negative 2xy squared. Okay, then we'll do the last with the y squared. Y squared times x stays the same. And y cubed. Okay, remember that the order of your x's and y's does not matter. Okay, so it might be difficult for some of you guys to see that xy squared here and y squared x are actually the same. They're like terms. Okay, you can actually add or subtract them. So just make sure you think about that when you're writing them. It might be helpful for you guys to just always write the x's first and then the y's, no matter the way you're multiplying. That's probably the best way to do it. But I just wanted to show you, just in case you get to a situation like this, these are like terms. So combine everything you can. X cubed, you can't combine with anything. X squared y minus 2x squared y is negative x squared y. Negative 2xy squared plus xy squared is going to be negative xy squared. And your y cubed at the end there. It looks just like that. Last one, trinomial times a trinomial. Okay, luckily you see that there's a lot of similarities between these, so you're probably going to get some cancellations, but we're going to go through the whole thing anyway. Okay, so you have to distribute each one. All right, from this first one, we're going to take the 3x, distribute it everywhere. And we'll get 9x squared. I'm going to need more space. 9x squared minus 3xy minus 3x. Okay, then the same thing with the y. So plus 3x plus, oh, not plus, I apologize. Should be a minus. Minus y squared minus y. And the same thing with the 1. The 1 will have a 3x minus y minus 1. Okay? Now with that, you got to combine all of our like terms. So this 9x squared, there's no like terms, so just leave it as it is. Minus 3xy does not have any. Oh, it does. Oh, where am I at? Wait, I made a mistake. There's supposed to be a y there. Sorry. The y distributed to the 3x should have been a plus 3xy. Okay, so your negative 3xy and your positive 3xy are going to cancel out. So they're gone. Your minus 3x and your plus 3x go away. and we still have a minus y squared minus 2y and minus 1.